Hi, this is Troy with Willpower Wheels and also with FRC, First Robotics Team 1014. What I want to show you today is walk you through a slideshow showing you the different pieces and parts of Will's Power Wheel modification. This is the original Willpower Wheel, and this was built for my son Will, who has Down syndrome. First, I'm going to walk you through the structural parts. So we started with one of these portable high chairs, and we screwed it to a piece of wood and then bolted that piece of wood to the Jeep at 3 locations. You can see we used thumb bolts and washers to secure the wood to the Jeep, and we also secured these 3 nuts to the Jeep itself. The steering for the Jeep was this linear actuator. Now this particular linear actuator has a potentiometer built in so that we get the positioning, and there's how we tied it into the steering linkage. You can also see we put some LED lights underneath for effect. We did wire in a fuse to the battery and also this on-off switch, just the main power. But other than that, all the power gets routed through to the underseat cavity of the Jeep. The pedal in the shifter, we did leave in the Jeep, and we have wired them as digital inputs to the Arduino, so we do read those values in. My goal was to make it so that the Jeep could still be driven by my daughters, or when Will gets old enough to drive it in its original state. We just read them as digital inputs now instead. Here you can see the underseat cavity of the Jeep, where we have the Arduino, and on this Arduino is the USB host shield adapter so that we can plug in this Xbox 360 wireless receiver, and that will get taken the inputs from the Xbox 360 controller and the Xbox 360 wheel. They both act as regular old Xbox 360 controllers. Here is the Victor speed controller that we use to control the speed of the 2 drive motors, 12-volt motors, and it is connected to the Arduino by PWM. The spike here is connected to the linear actuator that controls the steering. So we get the feedback from the potentiometer and then drive the spike accordingly forward or backwards to match that position of the stick. We have a 12-volt to 5-volt power converter, and that is strictly to power the LED lights. They are Adafruit NeoPixels, require 5 volts. And here is our Xbox 360 wheel. The robot was programmed to drive so that the left stick's x-axis steers it. Well, it turns out that in this Xbox 360 wheel, the turning of the wheel acts as the Xbox 360 x-axis of the left stick. But then to make it go, we actually programmed it so that the right bumper, the R1 button, makes the car go, and I actually have it go according to whatever position the shifter's in, so turtle, rabbit, or reverse, as the Fisher-Price company has labeled the Jeep. So we wired in this capacitive touch sensor. It is a lunchbox lid, so we've got the metallic, and we've wired an Arduino Pro Mini to it. So we opened up the Xbox 360 steering wheel. We wired these 2 leads coming out of the Xbox 360 wheel to the switch representing the right bumper paddle. We then wired that to this relay, and that relay is switched by this Arduino Pro Mini, and there's a transistor in there as well. We then soldered one of the digital inputs of the Arduino Pro Mini to the lid, and then wrote some code to read that in as a capacitive touch sensor. We've also wired in this grounding strap that we attached to Will's leg underneath, just to get a much better reading from that capacitive touch sensor. And then he can control the forward motion of the Jeep just by touching that Xbox, or that lunchbox lid.